Hello friends, a very good morning to all the students. Am I audible to all? Okay, thank you friends for your responses. So dear students, if you remember in the last lecture, we have started the simplest chapter of basic mechanical engineering. We have started the eighth unit, eighth chapter, that is the pumps. So let me ask you some of the basic questions of the topics which we have discussed in the last lecture. So dear friends, anybody can give me the answer in the chat box. What do you mean by the static head? What do you mean by the static head? I am repeating the question once again. What do you mean by the static head in context of the pumps terminology? Okay, so I have received the responses, the answers of the students in the chat box. All the students, those who have responded me in the chat box, I am getting the perfect answers from all the students. Very good students, as it was expected from you all, intelligent as well as the good students. So the static head is nothing but the summation of the suction head and the delivery head. And if we want to write down mathematically, then we can represent it as HST is equal to HS plus HB. Very good students, I have received the maximum responses for this particular question. Let me ask you one another question. What is the output power of the pump? What is the output power of the pump? Or other way, which power is considered as the output power of the pump? Okay, so again I have started getting the responses from the students. Okay, I am seeing your answers in the chat box. Majority of the students have responded me in the chat box. Okay, so that is the right answer. The output power of the pump, that is the water power. It is denoted by PW and the equation is rho GQ into HM, where HM is nothing but the manometric head. So friends, let us now proceed further with the discussion of the pumps. So these are the main contents I am going to discuss in the current session. First, we will be understanding some of the basic concepts related to the reciprocating pumps. Then we will be understanding the different classifications of the reciprocating pumps. And we will be understanding the concepts of the different reciprocating pumps. And finally, we will understand the concept related to the air chamber as well as the air vessel. So let us start with the discussion. So the reciprocating pump is a type of the positive displacement pump. And friends, if you remember that in the positive displacement pump, a definite quantity of the liquid is displaced by the simple to and fro motion of the pump. And if the working element undergoes the to and fro motion, or in technical sense can be considered as a reciprocating motion, then that pump is termed as the reciprocating pump. So reciprocating pump is a type of the positive displacement pump. This pump operates on the principle of the actual displacement or the pushing of the liquid by the mechanical element that can be a piston or a plunger, and these mechanical elements they execute the reciprocating motion in a closely fitted cylinder. Remember friends, for the working of this pump, the reciprocating pump, the most important thing to be remembered is that the mechanical element will be undergoing the reciprocating motion. In simple terms, the reciprocating motion is considered as the to and fro motion. In this type of the pump, the liquid is alternately drawn from the sump or can be considered as the suction tank, and the liquid is filled into the suction side of the cylinder. Then further the liquid is passed on to the discharge side of the cylinder, and finally it is removed from the pump. So this is the simple basic understanding related to the reciprocating pump. The important points in this discussion you need to remember: the reciprocating pump is a type of the positive displacement pump, and in this pump the working principle is the simple reciprocating motion of the mechanical element. And by this reciprocating motion, the pumping action will be taking place, and because of this pumping action, now the liquid will be displaced from one place to the another place. Let us proceed further with the next point of the reciprocating pump, that is the classification of the reciprocating pump. The reciprocating pumps are classified according to the bases of the different parameters. So the first classification is according to the type of the reciprocating member, which is the mechanical element which is undergoing the reciprocating motion. On the basis of this criteria, the reciprocating pumps are classified as the piston pump, the plunger pump, as well as the bucket pump. And friends, let me tell you that in this lecture only we will be discussing all these three types of the pumps in the detail. Basically, the plunger is also a modified form of the piston. And in the bucket pump also we are using the piston, but on the piston we are using a bucket valve. So now the piston is named as the bucket, and hence it is known as the bucket. Very easy to understand. Let us proceed further with the next classification. The next classification is done according to the action of the liquid upon the piston ends. How the liquid is acting on the piston ends. The types of the reciprocating pumps according to this parameter are the single acting piston pump and the double acting piston pump. Try to understand the names. In the single acting piston pump, the action of the liquid will be on only one side of the piston. Both the strokes, the suction as well as the delivery strokes, both the strokes will be taking place on the same side of the piston or on the single side of the piston. Hence, this pump is known as the single acting piston pump. And when we consider the double acting piston pump, the action of the liquid will be on both the sides of the piston. As I am proceeding further in this lecture, also we will be understanding in detail the single acting piston pump as well as the double acting piston pump. I will show you the images of these pumps and I will explain you the working. Then the concept will be perfectly clear in your minds. Let us proceed further with the last classification of the reciprocating pump. The classification is done according to the method of the derivation. There are two types. First is the direct acting pump and second is the power pump. The direct acting pump is a type of the pump which is directly coupled to the steam engine, which we have already understood in the heat engines. The steam engines are the examples of the external combustion engines. So if the pump is directly connected to that steam engines, then they are considered as the direct acting pump. And if the pump is coupled with the electric motor or the internal combustion engine, then that type of the pump is known as the power pump. So this is the main difference, the points to be remembered in context of the direct acting pump and the power pump. Dear students, let me ask you, are you understanding these concepts? Are you understanding the points which I am explaining in context of the reciprocating pumps? We have understood up till now the basic concept of the reciprocating pump and we have discussed the classification of the reciprocating pump. Thank you all for your positive answers in the chat box. So now friends, let us proceed further and understand the different types of the reciprocating pumps. So the first and the most important type of the reciprocating pump, that is the single acting piston pump. Most important question can be asked in your theoretical examination. And whenever this question is asked in your examination, then firstly you need to draw the figure of the single acting piston pump. Remember friends, mine all figures will be different compared to the figures which are given in your textbook. But if the logics are clear, if you are understanding the technical points, then you can easily write down the answers in the examination. So from the name only we can understand that in this type of the pump, the action of the liquid will be on one side of the piston and the reciprocating member in this pump will be the piston. In order to remember this diagram, first we need to remember the notations, the labeling of the diagram. So try to understand its master key. For the suction side, we need to remember three names. That is the suction tank or the sump, suction pipe and the suction valve. Three names are with respect to the suction side. Repeating once again, the suction tank, suction pipe and the suction valve. Three names are with respect to the delivery side. In your textbook, the delivery tank will be mentioned. So delivery tank, delivery pipe and the delivery valve. So 3 and 3, 6 names we have remembered and the last 5 names are in context with the piston cylinder. Let us understand those 5 names: cylinder, piston, piston rod, connecting rod and the crank. So 6 plus 5, 11 main names you need to mention in this figure. And also additionally you need to note down the suction head, that is HS, and the delivery head, that is H. Remember friends, the suction valve and the delivery valve in this type of the pump are the non-return valves. These valves, they operate automatically by means of the pressure difference across the valves. I am repeating the point once again. The suction valve and the delivery valve both are the non-return valves. These valves, they operate automatically by means of the pressure difference created across the valves. So now friends, let us understand the working of the single acting piston pump. If you focus on my points, if you understand my points, I hope that working will be perfectly clear. In the working, we need to explain two strokes. The first stroke is considered as the forward stroke or the suction stroke. And second stroke is considered as the reverse stroke or the delivery stroke. So now let us understand the first stroke, that is known as the suction stroke or the forward stroke. In this stroke, the crank which is connected to the prime mover rotates from 0 to 180 degree. Repeating the point once again, the crank rotates from 0 to 180 degree. Because of this rotation of the crank, the piston moves from left to right. The piston will be moving from left to right. The arrow is shown in the diagram. As the piston is moving from left to right, on the back side of the piston, the vacuum will be created, the pressure difference will be created, and because of this pressure difference, the suction valve will be automatically opened and the liquid from the suction tank will be transferred to the cylinder. And when the piston has reached to its maximum outward length, maximum liquid will be filled into the cylinder. So now the pressure in the cylinder will be increased compared to the suction pipe. So at that point of the time, the suction valve will be automatically closed. That means the water which is filled into the cylinder cannot backflow in the suction tank. Is it clear to all the students? Are you understanding these points? Though I am getting in somewhat more details in order to understand the concepts, in order to understand the working. Okay, fine. Thank you for the responses. So now let us understand the second stroke, that is known as the backward stroke or the delivery stroke. In this stroke, now the crank will be rotating from 180 degree to 360 degree. The remaining rotation will be taking place of the crank. The piston which is initially at this position will be moving back to its original position. So piston will be moving from right to left as observed in this direction arrow. The water which is initially filled in the cylinder will be pressurized, compressed by the piston. So now the pressure in the cylinder will be increased significantly. At these higher pressure conditions, the delivery valve will be opened and now the water will be transferred to the delivery pipe and finally to the delivery tank. As the water has transferred to the delivery tank, now the pressure in the cylinder is reduced compared to the pressure of the delivery side. So automatically the delivery valve will be closed. So we can tell that the water which has filled in the delivery tank cannot backflow in the cylinder. And now again we have reached to the starting point. Both the valves are closed. The piston has reached to its initial condition and the crank has reached to its starting point, that is at 0 degree. Dear students, have you understood this logic? Mainly I am discussing the technical perspective in the textbook. Very simple points are mentioned in this pump. But for better understanding, I am going in somewhat details so that the picture is perfectly clear in your minds and you can understand the technical concepts of the pumps. I want the responses from majority of the students so that I can proceed further with the next type of the pump. Remember friends, in the single acting piston pump, two strokes are there. The suction stroke, that is the forward stroke, and the second stroke is the backward stroke or the delivery stroke. Thank you all for maximum responses in the chat box that you have understood this topic perfectly. Let us proceed further and understand the next type of the pump, that is the double acting piston pump. From the name only now we can understand that in this type of the pump, the liquid will be heating the piston from both the sides. There will be the action of the liquid from both the sides of the piston. So friends, it is nothing but the simple modification of the single acting piston. In this, we have added another suction line and another delivery line. Rest all the things that remain the same as respect to the single acting piston. Only the suction pipe is added, suction valve is added, and on the another side the delivery pipe is added and the delivery valve is added. So in this case we are having two suction pipes and two delivery pipes, and in each pipe we are having the individual suction valve and the delivery valve respectively. So in the working of the double acting piston pump, remember, just you need to mention the forward stroke and the backward stroke. In my figure, I am considering this direction to be the backward, and in the next I am considering this direction to be the forward. So now let us understand the first case, that is I am considering as the backward stroke. This shaft will be connected with the crank. So when the crank moves from 0 to 180 degree, the piston will be moving in this direction as shown by this arrow. So on the back side of the piston, the vacuum will be created. Because of this vacuum, because of these pressure differences, this suction valve will be opened and the liquid will be entering into the cylinder. The liquid will be filling into the cylinder on the back side of the piston. In the front of the piston, already the liquid will be collected. That collected liquid will be forced by the piston, compressed by the piston. So because of this pressure difference, again now the delivery valve, this delivery valve will be opened and that collected liquid will be discharged to the delivery tank. So friends, we can understand that during one stroke of the piston, during the same stroke on the piston, on one side the suction is taking place and on the second side of the piston the delivery is taking place. Hence we can tell that there is the action of the liquid on both the sides of the piston. Dear friends, are you understanding this concept? Are you understanding this logic of the double acting pump? I want the responses in the chat box. Okay, thank you for your answers. And some students are telling that they have perfectly understood. So it is very good from your side. So now friends, after completing this stroke, what is happening? In this side of the piston, there is no liquid, but in the front side of the piston, there is the liquid in the cylinder. So when here in this stroke, the crank moves from 180 to 360 degree, the piston will be moving back to its original position. So the liquid which is collected on the back side of the piston will be pressurized by the piston. Pressure difference will be created. Pressure will be increased. At this point of the time, this particular discharge valve will be opened and the water will be transferred to the delivery tank. Here in this side, since there was the no water, so the vacuum will be created. Because of these vacuum conditions, now this suction valve will be opened and new liquid will be filled into the cylinder and the piston will be reached to its initial condition. So friends, if I consider these as suction valve SA and these as suction valve SB, then during this stroke, the liquid enters from SA and the delivery takes place from DB. In this stroke, the suction takes place from SB and delivery takes place from DA. That is, there is the simple cross connection which is observed in this type of the pump. If the suction takes place from valve A, the delivery takes place from delivery valve B, and if the suction takes place from valve B, then the delivery takes place from delivery valve A, as it is mentioned in your textbook. So friends, if you understand this picture perfectly, the working perfectly, then we can tell that in this type of the pump, the suction and delivery takes place simultaneously. The suction and delivery takes place at the same time. But in the single acting pump, the suction and delivery does not take place at the same time. There is intermediate. On one time there is only suction, on the next time there is only delivery. But in the double acting pump, the suction delivery takes place simultaneously. That means at the same time. Dear friends, are you understanding these points? I am clubbing several points in order to go in depth of the working of the double acting piston pump. Have you understood this concept perfectly? Okay, thank you all for your answers in the chat box. So now let us proceed further and understand the next type of the pump, that is the plunger pump. So since this pump is not used in the major applications right now, so I am considering the image which is already given in your textbook. This is the same image of your textbook. The plunger is a modified form of the piston. In design of the piston, it is smaller in dimensions, therefore the stroke of the piston is larger. The piston can perform a larger stroke, but the plunger is having the larger dimensions, hence the plunger will be performing a shorter stroke. The stroke length of the piston will be larger than the stroke length of the plunger. This is the main difference between the piston and the plunger. In the image, you are seeing the gland, packing, stuffing box, glide bush. All these components are installed in the pump for covering the pump in order to minimize the leakage of the liquid. And other points are the same. We are observing the suction valve. This is the suction side. We are observing the delivery valve with the delivery. And the plunger will be operated by the handle. So whenever we are operating the handle, by the movement of the handle, the plunger will be lifted. Because of the lifting of the plunger, the suction valve will be opened. The water will be entering on the bottom side of the plunger, and when by the operating of the handle, when the plunger moves down, It will be pressurizing the liquid. So at this point, the delivery valve will be opened and the water will be delivered out of the pump. Remember friends, the working is very easy. Just by the top and down movement of the plunger, the suction and the delivery takes place. Is it clear to all? And for operating the plunger, we are provided with the handle. Is it clear to all? The plunger pump. Remember friends, in the plunger pump, the stroke length will be lesser as compared to the piston pump. Therefore, the space between the suction side and the delivery side is very minimum. Now let us proceed further and the bucket pump. So this is the image of the bucket pump. This is the practical image of the bucket pump. I hope majority of the students has seen this image. So anybody can give me the answer. What is the another name of the bucket pump? Observing the image, can you give me the another name of this pump? Very good. Majority of the students has responded me perfect answer. That is the hand pump. Remember friends, in this diagram I have used some different terminologies as compared to your textbook terminology. But understand the concept perfectly, then there will be no issue. In this pump, on the piston, we are having a different type of the valve. In my case, it is written check valve. In your case, it will be written the bucket valve. That will be on the top of the piston. We are provided with the handle, the piston rod, the suction side. This is the check valve, which is known as the suction valve. The sealing rings are provided with the bucket valve, and this is the water outlet. Now let us understand the working of the bucket pump. Dear friends, firstly make a correction in your textbook of the bucket pump. In the textbook, in the description of the bucket pump, you are given the suction stroke and the discharge stroke. So in the suction, write down the upward stroke. Cancel the point of suction and that point mark the heading upward stroke, and in the second point mark the heading downward stroke. So these are the two corrections in your textbook. So now let us understand the working. Whenever the handle is operated, because of the movement of the piston rod moves up. So the piston which is connected with the piston rod also moves up. The water which is initially filled into the cylinder is transferred to the outlet side, and on the bottom side of the piston the vacuum will be created. At that point the suction valve will be opened and the new water will be entered on the bottom side of the piston. So when the handle is moved down, the piston rod moves up, the piston moves up, the delivery valve opens, so delivery takes place. The suction valve opens, so the suction takes place. Remember friends, in this stroke, the suction and delivery, both the strokes that take place simultaneously. But in this stroke, the bucket valve remains closed. Next, now what will happen in the second stroke, when the handle is lifted back to its original position, now the piston rod would be moving in the downward direction. As the piston is moving in the downward direction at one point of the time, the bucket valve of the piston will be opened. So by the opening of the bucket valve, the water which is filled below the piston will be transferred on the top side of the piston. And the piston has reached to its minimum position. Once the water will be lifted up, the bucket valve will be automatically closed. So the water which is filled on the top side of the piston cannot move back to the suction side. So just think over these points, just understand the concepts which are given in your textbook. Still, if you are having any doubt, you are free to ask me, just message me or you can call me. I will be clearing your doubts. Bucket pump, a practical pump, since it is operated by the hand, it is also known as the hand pump. So these are the different types of the reciprocating pumps we have discussed. Now let us proceed further with the last topic of this session, that is the air chamber or air vessel. The air vessel is a closed chamber fitted on the suction as well as the delivery side near the pump cylinder in order to reduce the accelerating head. The functions of the air chamber on the suction side are it reduces the possibility of separation. Also, the pump can be run at the higher speed. The length of the suction pipe can be increased below the air vessel. And if we consider the function on the delivery side, the large amount of the power consumed in supplying the accelerating head can be saved, and also the constant rate of discharge can be ensured. So this is the simple sketch of the air chamber or the air vessel. As you are observing that this chamber, one chamber is attached on the suction side, the another chamber is attached on the delivery side. And in this chamber, the compressed air is filled. Let us proceed further and understand the basics of the air chamber. So the top of the vessel contains the compressed air which can contract or expand to absorb most of the pressure fluctuations. When the pressure rises, the water in excess of the main discharge is forced into the air vessel, thereby compressing the air which is already filled in the vessel. Now when the water pressure in the pipe falls, this compressed air ejects the water out of the vessel. So the air vessel can act like an intermediate reservoir or the tank. On the suction side, the water first accumulates here in the air vessel and then it is transferred to the cylinder. On the delivery side, again, the water first goes to the air vessel and then it flows with a uniform velocity to the delivery tank. So friends, these are some of the basic, very fundamental concepts related to the air chamber or the air vessel. And if we consider the industrial perspective, wherever they are using the pumps, compulsorily they are using the air chamber or the air vessel in order to get the uniform flow rate from the pump. In order to get the uniform flow at the delivery side, at the industrial sectors, majority of the people are using the air chambers with the pump. If you understand this point, now if you go through the points which are mentioned in your textbook, you will understand the concepts, and still if you are having any doubts, you are free to ask. So friends, with this, I am concluding this session from my side. Thank you for watching the current session. Have a nice day. Now friends, I am having some few minutes left in the meeting. If you are having any question, you can ask me in the chat box. Any questions from any student? Okay, fine. Thank you all. See you in the next lecture.